Hello, this is going to be a indefinite integration homework help. This is for my calculus students, the girls of calculus, and my worldwide audience of YouTube subscribers and viewers. I appreciate all of you being here. We're going to go over this set of 18 problems. I'm going to work out a sample of 6 of these, and I'm going to work out the problems 3, 6, 9. Let's see, 3, 6, 9, 12, 15. Anyway, 6 of them. We will see them. We have this first one I'm going to work out is this one, the integral of quantity 6 plus 2x dx. And to work this one out, I'm going to split this into 2 separate integrals. So I'm going to integrate this as the integral of 6 dx and that's going to be plus the integral of 2 dx, and we're going to take these numbers on the outside, so that's going to be 6 times the integral of dx, and I made a mistake here already. It's going to be 2x dx. There we go. Yeah, transcribing can be sometimes the hardest part of this. Plus 2 times the integral of x dx, and now we're prepared to integrate, so we have the integral of dx is x, so we're going to have 6x, and that's going to be plus 2, and we have x, and we bump up and divide, so that's going to be x to the power of 1 already, so that's going to be 2 over 2. We divide by the power we raise 2 plus our constant of integration c. And then just kind of cleaning up this a little bit, writing perhaps in standard form, we can rewrite this as x squared plus 6x plus c. And so that's going to be problem 3 worked out. Next, let's look at problem 6. Okay, we have a similar problem to problem 3. We're going to split this integral up into 2 pieces. So we're going to have the first piece here, this 3x cubed, will be 3 times the integral of x cubed dx. And it's going to be minus 4 times the integral of x squared dx. Okay, and then just integrating here, we have 3 and we have x cubed is going to be raised 1 power to 4, and then we can divide by the power we raised 2, which is 3, and then minus 4, and it's going to be 4 times x to the 3rd power divided by 3, which is the power we raised 2, and that's going to be plus our constant of integration c. So that's all we have to problem number 6. Okay, let's go on to problem number 9. So here we have the integral of quantity 2 minus 1 over x to the 5th power plus 7 over x cubed dx. So I'm going to rewrite this in what I like to call calculus friendly form, if that's a possibility. So we're going to have the integral of 2 dx, and then we're going to have minus the integral of 1 x to the negative fifth power. Okay, that's using the rules of exponents. Plus, I'm going to take this 7 out front like this, out sort of for the integral symbol, and we have x to the negative third power dx. And I neglected to put our dx right over here next to this x to the fifth. So let me just go ahead and write this out a little more neatly. So we have dx here, and then we have plus 7, the integral of x to the negative 3 power dx. And now integrating, we're going to have 2x, and what we have is we have it's essentially 2x to the 0 power, and so we raise this x to the 0 power to 1 and divide by 1, so that's what it ends up being, just 2x. And we have minus, we have x to the negative 5 plus 1 is going to be negative 4, and we're going to divide by the power we raised to, we're going to divide by negative 4. And then for this next one we have plus 7, and then we're going to have x to the negative 3 plus 1 is negative 2, and we're going to divide by negative 2, and we're going to add our constant of integration c, and from here on out it's just going to be a matter of cleaning up. So we're going to have 2x, and this negative divided by negative 4 is going to end up being plus 1 over 4, and x to the negative 4 will become 1 over x to the 4th power. And then finally we have 7 divided by negative 2 is going to be minus, and we're going to have 7 over 2, and x to the negative 2 power shows up in the denominator as x squared, plus again our constant of integration c. So we got to kind of take careful note of these signs, make sure that we are following the cancellation of signs, having our coefficients in the right place, which ones to put in the numerator, which in the denominator. So those are things to look after. Okay, next let's look at problem 12. We have the integral of x to the 3/4 minus 1 over x to the 3/4 power. So just rewriting this in friendly form, we put x to the 3/4 power dx, integral of x to the 3/4 power dx, minus the integral of x to the, in the denominator, x to the 3/4 power is going to be in the numerator x to the negative 3/4 power dx. Okay? All right, let's go ahead and integrate. What we have now is our integration is going to be x to the, what is 3/4 plus 1? Well, that's going to be 7/4, so this could be x to the 7/4. And we're going to divide by the power we raised to, which was 7/4. And then we have minus, we have x to the, what's negative 3/4 plus 1? Well, that's going to be x to the 1/4, and we're going to divide by 1/4. which is the power we raised 2, plus our constant of integration c. And now, going back to our 7th grade math, we divided by a fraction which is the same as multiplying by a reciprocal. So what we have is this divided by 7/4 becomes multiplied by 4/7. And we have x to the 7/4 power. And then we have this other one here. We're dividing by 1/4, which is the same as multiplying by 4. So we have 4x to the 1/4 power plus, which we never want to forget, our constant of integration, c. So that's what that is. All right, let's go on to number 13, not number 15. And so here we have 4 times quantity x, 3x minus 2 cubed. And so cubing is going to be, that's working out quite an expansion. So we're going to go back to our binomial theorem expansion, and if you recall, a power 3 expansion is done by the coefficients 1, 3, 3, 1, and you can work it out quickly with the Pascal's triangle, but I won't even do that. So I'm going to go ahead and work out, I'm going to go ahead and take this piece here, this quantity 3x minus 2 cubed, and just work on that. And then we're going to take this 4 on the outside, so we'll see what that looks like. So just working this out, I'm going to just write this over to the left. We have quantity 3x minus 2 cubed. That's going to be equal to the coefficient 1 times our first term, which is 3x cubed, and then we're going to have this minus 2 to the 0 power, and that's going to be 1. So this negative 2 to the power of 0, and then we have plus, we're going to have this coefficient here, and remember the coefficients are going to be 1, 3, 3, 1, so it's going to be 3 here, and so we're going to have 3x squared, okay, that's going to be 3x squared. Let me see if I get this right. It's 3, and then we'll have here 3x, and we're going to square that, and then we're going to have this negative 2 to the first power, and then we're going to have plus our next spot for our next coefficient here, 3, and then we're going to have this 3x, our first term, to the first power, times this negative 2 squared, and finally we have this plus blank. We know that's going to be 1. So when the blanks are filled out as 1, 3, 3, 1, and we're going to have this 3x to the 0 power, and times this negative 2 to the third power. And so we just simplify this all out, which should be pretty easy to do. So for the first one here, we have 1 and 3 cubed is 27. So we're going to have 27x cubed. And this negative 2 to the 0 power, that's 1. And this next term we have is going to be 3 times 3 squared. That's going to be 3 squared is 9 times 3, that's 27, and 27 times negative 2 is going to be negative 54. So I have minus 54. And we have x squared. Okay, our next one is we're going to have 3 times 3 times negative 2 squared. So 3 times 3 is 9, and 9 times 4 is 36, and this negative is going to be made positive. So we're going to have plus 36x. And then we're going to have the last one, we're going to have minus, well, we're going to have x to the 0 power, and this negative 2 cubed is going to be negative 8. And so this 4-term polynomial is going to replace this quantity 3x minus 2 cubed. And so just writing down here below with this inset, we're going to have, I'm going to put this 4 on the outside. I'm going to write times the integral of 27. Okay, my pen's going a little glitchy. 27 x cubed minus 54x squared okay, and then we have plus 36x and minus 8, and it's going to be dx. Okay, now we can just work all this together. So just kind of writing these out individually, we're going to have 4 times all of these. So 4 times 27, I believe that's going to be 108. So this is going to be equal to 108 the integral of x to the 4th dx, and then we're going to have the next one, we're going to have 4 times 54, which is going to be 216, so minus 216 the integral of x squared dx, and then we're going to have 4 times 36, well that's going to be 144 I think, okay, plus 144 the integral of x dx, and finally we're going to have minus 4 times 8, which is going to be 32 integral of dx. Okay, we should be able to put everything together pretty well. And so we're going to have the integral of 108 x to the 4th power dx is going to be 108. And we're going to have x to the 5th power divided by 5. And then next we're going to have minus 216. We'll have x cubed. We're going to divide by the power we raised to, which is 3. And I think that 216 is divisible by 3, so we're going to come and clean that up. The next one we have is plus 144 that's 144x squared, and we're going to divide by the power we raised to, which is 2, and then we're going to have finally minus 32 x. and we're going to have to divide by 1. That just leaves us the same. So let's just let's clean this up a little bit. So we're just going to leave this as 108 fifths. Oh, and what did I forget to do? Add the C. Don't forget to add the C. Okay, and that's going to be x to the 5th power. And next we have 216 divided by 3. And we divide that by 3. And that pen is glitchy on me. 3. So we're going to get 7 here. Times that's 7 times 3 is 21. Bring down the 6. So that'll be 2. So we're going to get 72. So minus 72 x cubed. And then 144 divided by 2, that's going to be 72. So plus 72x squared. And then minus 32x plus c. Okay, that's going to be it. A lot of places to make mistakes there. I'm not 100% sure I got everything right, but comment if there's something amiss there. I'd appreciate some help with that. The last one we're going to look at is number 18. And number 18, we have this quantity 3x minus 2 squared over square root of x. So the first thing, as in problem 15, I'm going to expand this 3x minus 2 squared, this quantity 3x minus 2, as I take this 3x minus 2, and when we square that, what we get is we're going to get the first term squared, which is going to be equal to 9x squared, and then 2 times the first and the last term. Well, 3x times negative 2 is negative 6x, and times 2 of that is going to be minus 12x, and then plus the last term squared is going to be plus 4. And so that's our expansion right there. And so we're going to go ahead and rewrite using this expanded trinomial. So just rewriting like this, we're going to have this going to be equal to, we have now 9x squared. And what I'm going to do is, I'm just going to go ahead and write this up. 9x squared minus 12x plus 4 over, and I'm going to rewrite this square root of x as x to the 1/2 power, and finally dx on the outside. And we put dx on the outside, we have to realize that the dx applies to all of this quantity. Okay, now just kind of taking each one of these at a time, I'm going to leave myself some room here. We're going to have the integral of, I'm going to use this 9 on the outside, so here's 9, integral of, we have x squared over x to the 1/2 power, and using the rule of exponents, which is of quotient is x to the a over x to the power of b is x to the power of a minus b. So using that technique, what we have is x squared divided by x to the 1/2 power is going to be x to the 3/2 power dx. Okay, and next we have negative minus 12, the integral of x to the first power divided by x to the 1/2 power. Well, that's going to be x to the 1/2 power. 1 minus 1/2 is 1/2. And that's going to be dx also. And then we have this 4 over x to the 1/2 power, so that's going to be plus 4. We're going to have the integral of x to the negative 1/2 power dx. So now we have this all in we call calculus friendly form, if you believe there's such a thing as that. So we're going to have is equals 9, and what we're going to do is we're going to have the integral of x to the 3/2 power is x to the 5/2, and we're going to have to divide by 5/2, which is the same as multiplying by 2/5. So I'm just going to go ahead and put here the fraction 2/5 right out front like this. And the next one we're going to have is minus 12, and we're going to have x to the 1/2 plus 1 is going to be x to the 3/2, and which means we're going to divide by 3/2, which is going to be the same as multiplying by 2/3. Okay, then now we have plus 4, and we have x to the negative 1/2 plus 1 is going to be to the 1/2. And now we're going to divide by 1/2, which is the same as multiplying by 2 over 1, which is 2. And then we're going to add c, our constant of integration. So now it's just a matter of cleaning up. So we have 9 times 2 over 5 is going to be 18/5 x to the 5/2 power. And then we're going to have 12 times 2, which is 24, divided by 3, which is 8. So 24 divided by 3 is 8. So we have 8 x to the 3/2 power. And then we're going to have this next one here is we have 4 times 2, which is 8. So plus 8 x to the 1/2 power. And then add c, our constant of integration. And now we can put this back in radical form, because the half there is going to be a square root. So let's go ahead and rewrite this last here. This is going to be like our final answer. We have 18/5. Let's make that a little neater. So you have 18/5. Then we're going to have x to the 5/2 power is going to be the square root of x to the 5th power minus 8. We're going to have x to the 3/2 power is going to be the square root of x cubed. And then finally we're going to have plus 8 x to the 1/2 power square root of x plus c. And so that should be all of it right there. And again, a lot of moves in this, a lot of simplifying to be done here. So I'm not, again, 100% sure that's right, but I welcome comments to check if you got the same thing that I did. I hope you did, but if not, please let me know. I appreciate you viewing today and participating. Take care.